So this is video number 3 for lesson 13. I went ahead and worked out the first problem. I went ahead and put the 18x cubed to the other side. I'm going to walk you through this real quick. Put this 18x cubed on the other side and wrote it in order, and I factored out the common factor, which was 3x. And then I went ahead and found that this was an equation in quadratic form. I factored it out, and then I knew that x squared minus 1 could also be factored here. I then set each factor equal to 0 and solve for x. So x comes up to be square root 5, negative square root 5, 1, negative 1, or 0. So those are all the roots. I'm going to ask you to pause the video and see if you can do example 6, all 3 of those. See if you can try to get those answers on your own. Okay, so go ahead and try that, and then we'll come back after you've paused the video and tried it, and see how we do. Okay, on the left here, I've got the solutions. I'm going to just zoom into one each at a time here. So if you look, I've factored by grouping. So I grouped these two, and then I factored out 2 and 2x squared and 10. And then rather than, I just went ahead and factored out the 2, so it's 2 times x squared plus 5, so this would be 2x squared plus 10. I just factored out the 2. I have x squared plus 5 times x minus 4. So I get x is plus or minus root 5I, and x equals 4. Those are the 3 solutions. And then we continue to the next problem, x squared minus 216. If I set that equal to 0, and then I went ahead and factored that because that is the difference of 2 cubes. I factored that to both sides. Now there might be a temptation to just take the cube root of 216 and get the real answer. The trouble is you won't get the 2 imaginary solutions or complex solutions, which are right here. So you'll need to solve this using the quadratic formula. If you use the quadratic formula, I believe you should get to this answer. I believe it's something to the effect of like negative 6 plus or minus square root of negative 108 all over 2. Give that a try. And if I did make a mistake on that, let me know, but I think it's okay. All right. The biggest thing, though, is to make sure that you actually split that up into both of its factors and then solve for both of them set equal to 0. And then in the last problem here, we've got z to the 4th, that plus is 6z squared minus 27. I went ahead and factored that in quadratic form, set both of them equal to 0. I get z equals plus or minus 3i, and z equals plus or minus square root of 3. Okay? All right. We're going to go on to the next problem. Okay, so we're going to show that x plus 2i is a factor of this 2x cubed minus x squared plus 8x minus 4. If x plus 2i is a factor, then it seems to me that negative 2i plugged into this equation should give us 0. Now, let's say that again. If x plus 2i is a factor, then it seems reasonable that this value, if I set it equal to 0, this is a 0 of the function. So it should be that negative 2i is a 0. We'll call it a root, not a 0. That sounds better. Okay. Plug negative 2i into this equation and tell me, or see what you come up with. Pause the video now. Okay, so I plugged negative 2i into the equation, and I went ahead and calculated negative 2i cubed, which is negative 8i cubed. I cubed is negative I. Negative 8 times negative I is plus, times 2 is plus 16i. Then I have minus a minus 2i squared, and this minus 2i squared becomes 4, or minus 2i becomes 4i squared. I squared is negative 1, means this is negative 4, minus a minus 4 is plus 4. Then 8 times negative 2i gives me minus 16i, which is going to cancel out. That's going to go away. And then we have the minus 4 here. So yes, this equals 0, and we are happy because we have shown that x plus 2i is a factor of that polynomial. So again, once you have something that, if you're trying to prove something as a factor, like x minus something or x plus something, you can plug whatever will make that 0 into the equation and or into the function, and you should get 0. All right, that's it for lesson 13. Have a nice day.